Hello, guys. Welcome to our today's webinar. It's pleasure having you all here. Today we will dwell on the remote sensing solution for businesses, basically continuing series of our webinars. And today we would like to tell you a little bit more about EOSDA Forest Monitoring solution. My name is Yevhenii Marchenko. I'm account executive at EOSDA. Also, I have my colleagues who will be assisting me, joining me at this webinar. So while we're waiting for everybody else to join, I just wanted to make a quick round of introduction to introduce our today's speakers. Kostiantyn, if you would like to go ahead.
Yes, hi for all. I am Kostiantyn, and I am a product manager at EOSDA, which is responsible for the development and growth of forest monitoring. Today, I will tell you a little bit about several solutions and examples where the solution were applied. Thank you.
Vera.
Yes, hi everyone. My name is Vera Petryk. I'm Chief Marketing Officer at EOS Data Analytics. And today I will dwell a little bit more about the market, who is our user persona, and our sustainability commitment. Thanks.
And Dmitry.
Hi, I'm Dmitriy Hramov, PhD and Senior Researcher in EOSDA R&D Department. Thank you.
Thank you, guys. We also have Kirill's. He'll be our moderator in chat. He'll be managing all the questions. By the way, guys, if you could put the please plus sign if you can hear and see us well, just to test the audio before we dive into the webinar. So if you could put a plus sign, yeah, I could see that it's working properly. And also, yeah, if you could type where you're from, where you're joining these webinars, also would be cool to know, to understand, yeah, the geography of our listeners, of our audience. Yeah, I see people joining us from India, cool. Canada, nice. Sweden, beautiful. Thank you so much, guys. We're pleased to have you here, and yeah, I hope this time will be worthwhile, and we will be able to provide some quality data and tell you a little bit more about our forest monitoring solution. So yeah, today, here is the agenda. First of all, I would like to tell a couple of words about our company, EOSDA, for those of you who join in our webinars for the first time. Then we will move to remote sensing, what it is in forest management, and what kind of data we use in EOSDA. And the next point would be actually the explanation about our services that we have in our forest monitoring platform. This is deforestation, forest cover, tree species identification, forest health, burned area, and reforestation. And also, what is the application, what are the benefits of using these solutions for your business or for your organizations. And after each of the service, after each of the solutions, we will have a short use case study where we could tell you on the example how it's been used and what is the application of the service. Next year, we will have, after the use cases here, we will have a short quiz in the middle of the presentation before we switch to Vera part about sustainability, how our solution is used for nonprofit organizations and how it could be used for basically combating the climate change. At the end, we will have a quick look at our EOS set. This is the satellite that has been launched at the beginning of the year by our company, and how we're going to use EOS set in forest monitoring. And at the end, we will have a Q&A session. So guys, please feel free to leave your questions in chat, and we will answer most of them at the end of the session. And for those of you who are not going to get answer right now live, we're going to reply via email. Plus, we will send you presentation and recording of this webinar in a couple of days after the event. So if you miss something, so you'll be able to check the presentation and also watch the video again. So yeah, let's dive in, and yeah, let's start with a few words about EOSDA. So basically, it stands for EOS Data Analytics, and our company was providing solutions since 2015. Our main expertise, this is satellite image and data analytics, which we provide to our clients to make better decisions. Our company is 220 plus people, including R&D, data scientists, software developers, and so on. And at this moment, our primary focus, this is agriculture and forestry. We have offices located in Eastern Europe, the headquarters of the company located in Menlo Park, California. Here you can see that actually our company, together with our sister companies, we comprise organizations which is called Noosphere Ventures. And our companies all together, we build this vertically integrated structure, which includes upstream, midstream, and downstream space segments. In EOSDA, we focused on analyzing data, analyzing satellite imagery, and providing analytics in form of our solutions as forest monitoring platform, land viewer, or as a custom solutions. But also other companies like Flight Control, Dragonfly, we actually developed, we assembled our first satellite, EOS Sat, so we have capacity of developing sensors ourselves and managing this data. So basically this is something that stands out us from rest of the crowd. So basically we're not only providing solutions via software, but also capable of building our own hardware. And this data, this unique data that we acquire with the help of our satellite will be used to provide even better quality insights and information to you. Speaking about the other current portfolio that we have, this is a forest monitoring platform that we're gonna dive in more details. This is also a crop monitoring platform and API for monitoring agricultural lands, and this is also land viewer. A land viewer is a really cool service. This is all-in-one platform that provides analytics, and you can search images from multiple providers in these platforms. Plus, it's free. Per day, you can watch 10 images for free, and we have a lot of clients from forestry who's using this platform. So guys, yeah, feel free to check it out and see it for yourself. And before we switch to actually covering our forest monitoring services, I would like to dedicate just a few minutes of time to go over what data is used in remote sensing for the forest management. So as you can see, it could be spaceborne, airborne, and ground-based. And in EOSDA, we use spaceborne and also ground-based segment. Spaceborne segment because it's applicable globally. It has global coverage, and such sensors as Sentinel-1 and Sentinel-2, they have high resolution up to 10 meters. This is also, if you're speaking about Sentinel-2, multispectral resolution satellite. So this data could be used worldwide. It's open source data, so our solutions is cost effective. In case where we need to have high resolution data, we would need to purchase this data commercially, so this could increase the cost of the project. But yeah, as you can see here, so we use Sentinel-1 and 2, which is optical and radar satellite. If we need to get access to historical data before 2015, we could use Landsat 4, Landsat 5, and other satellites. For some of the project as tree species identification or biomass estimation, we use ground-based data, so we would require to have data collected on the ground to be able to train our artificial intelligence. In this case, this is most of the time neural networks to automatically recognize tree species or make the assessment of the ground biomass. And let's go ahead and cover the first service that we have. This is Deforestation, and I think Kostiantyn will cover this solution.
Yes, thank you. So let's go. Deforestation is our basic solution, which can be used in different cases. Our solution is based on Sentinel-2 optic images with a resolution of 10 meters per pixel and Sentinel-1 radar images with a resolution of 20 meters per pixel. And of course, our EOS Sat, one with a resolution of 3 meters per pixel. It is caused by our wish to decrease final cost for our customers. But in general, we can use any satellite images with higher or lower resolution for different cases. On the first slide, you can see an example for a stand in Australia, which is present in the user interface of Forest Monitoring. For each stand in the Deforestation solution, we classified 3 different types of land cover. Deforestation. It is colored in red, and it means that this area was deforested for this period. Forest cover. It is colored in green, and it means that this area covered of forest for this period. And last, it is other land type. It is colored in gray, and means that this area includes any other areas like roads, water bodies, buildings, so anything which isn't forest or deforestation. For this forest stand, we prepared analysis for several months, and now you can see how deforestation happens in different months. As you can see, each selected month shows where and how much deforestation has occurred. You can also observe the historical graph or changes for the past year. If this isn't enough, you can download a report in Excel and continue work with it. So I think that's all from my side regarding deforestation. Yevhenii, perhaps you would like to add something?
Yes, thank you, Kostiantyn. Yeah, just wanted to sum it up. So as you can see, we could make an assessment of deforestation for different periods. It could be on monthly basis, it could be quarterly or yearly, again, depending on the objectives of your project. Speaking about application, what cases deforestation could be used, it could be different cases, beginning from the assessment of the remote areas. For example, if your office located somewhere else and you need to make assessment of your forest area overseas or in some remote area. If you need to make assessment of the large areas, especially applicable for countries like Canada, Brazil, a lot of countries in African continent, and so on. Also, it could be used for tracking illegal logging. So in case you need to monitor some ingenious forest or any other areas, basically we could use deforestation as well as for monitoring of the supply chain, especially right now when we have legislation adopted in Europe. So every producer, every provider need to provide the proof that this is a sustainable produce. So this is the service that could be used, in this case, deforestation for tracking any changes in the forest cover. Back to you, Kostiantyn.
Thank you, Yevhenii. Yes, so next solution, I would like to talk about the monitoring forest cover. This is a specific case of the deforestation monitoring solution, which it is cheaper version. It is aimed scenarios where you need to monitor large territories and changes in your forest cover. In our opinion, this solution can be helpful for monitoring large areas several times per year. This solution also based on Sentinel-2 and Sentinel-1 images, and of course, EOSat-1 images. Types of land cover are the following. It is forest cover, of course, it is also colored in green, and other land type, it is colored in gray. For this forest stand, we prepare also an analysis for several months, and now you can see how forest cover changed from 2016 till 2023. Yes, so that's all about forest cover. Yevhenii, maybe you also would like to add something?
Thank you. Kostiantyn. Yeah, it was pretty comprehensive. I just wanted to add that we could provide also time series of reports starting from any year that you would like to check the forest cover change. So it could be more informative if, for example, provide report for each of the years so you could see the trend, the dynamics. And this information could be applicable for, again, inventory. It could be used for any organization or any companies who would like to purchase some forest area and would like to understand the dynamics of reforestation if this forest is growing. And also, basically, yeah, this is a good way to make assessment of the remote areas if you do not have possibility to go there and check it on the ground. But also, this is cost saving to use the remote sensing instead of on-ground monitoring. And the next one is the tree species identification. So we have a lot of requests from our clients asking for automated solution for identification of the tree species. Again, I will start with the application. So the application of this service could be different. First of all, this is inventory to understand what tree species you have in majority in your forest area. Secondly, it could be used for carbon projects because some of the tree species, they absorb CO2 with the higher level, with the higher intensity than the others. So also understanding for evaluation if you are planning to invest in any forest area, forest properties. Also, it could be used to understand, again, the composition of the forest. Some of the tree species, the invasive tree species, and you could use this for basically clearing those out, like acacia and others. Or vice versa, some of the tree species could be endangered, and basically you would like to have constant monitoring of those tree species for preservation. So based on this request, yeah, we developed this automated technology, which is based on the neural networks and allow us recognize automatically different tree species. But yeah, for this service located in other locations except Central Europe, because yeah, we have trained our model based on the ground data set from Central and Eastern Europe. So we have classification done for those three types of species. But if you would like to have this service in your climatic zone, for example, in Latin America, on African continent, in this case, we would need to have examples of your native tree species that we need to classify. This is ground data, and on the ground data, we mean coordinates of the tree species that you would like to classify. So it could be a group of the tree species with the centroid, basically with the coordinate, or it could be a polygon. So we'll be able to provide you instructions how to collect this data. Basically, we'll assist you in collecting this data for your possible projects. And yeah, the way we developed this technology, again, is based on the neural networks. So the first step while we were developing it, it was to do the complete land cover classification. So this is something that we can also do. We could classify up to 7 different classes, including artificial class, basically including all the roads or buildings, artificial man-made created infrastructure. This is also water bodies. We could recognize wetland, cropland, grassland, shrubs, and of course, forest cover. So while we were doing this development of this technology, we use on the example of the region in Ukraine. This is Ivano-Frankivsk region. The total size of this region about 1.4 million hectares. So as you can see, it's quite sizable area. So first step was to do the complete land cover classification. Once land cover classification was done, we did the first step of classification, coniferous with deciduous forest. So again, this might not be applicable for all the geographies, but yeah, it is applicable for those countries located in northern part of the hemispheres. So the next step, yeah, we did classification between those two kinds, and here we could see that in particular in this example, we have coniferous forest covering about 40% of the total area of the total forest area. So the whole size of this district is 1.4 million hectares. The forest cover 6,500,000 hectares, and yet the coniferous forest and deciduous forest is 40% to 60%. So while providing this service or any other services, we'll be able to provide these additional reports with the location visualization and also statistical information about the percentage and the amount of certain tree types if we will do this classification. So this was the next step, to actually classify these two types of the forest. And the next step actually was classification of all the tree types available at this area. So basically, our partner, they provided us ground data. This is examples of the specific tree types with the coordinates. So the total training size of the ground data was about 24,000 hectares. So if you could see, for example, the total size of this region, 1.4 million hectares. So the training size was about 24,000 hectares. And based on this training set, our scientists, they trained the neural network to recognize these tree species. So as you can see here, this is the final result, basically the classification according to these three types of species. And yeah, as I mentioned before, this is classification done for Central and Eastern Europe. So we have here tree species such as acacia, ash, maple, aspen, beech, oak, pine, spruce, and so on. So basically here, I could tell that the beech covers about 30% of the total forest cover, oak about 11%, spruce about 15%, and the rest of the trees, they also take less than 10% of the total area forest cover. So basically, this is kind of report that we could deliver at the end of your project, so provide the location and distribution of the targeted tree species in your project geography. Yeah, the last slide, basically, this is compositions of all the classification classes, so different type of classification classes, including forest area, agricultural area, combined with all the targeted tree species that we classified in Ivano-Frankivsk region. So here you can see enlargement, how it looks like. So some of the tree species in particular regions, they occupied more area, for example, like oak and so on. And now, yeah, we would like to switch to the platform. Yeah, Kostiantyn will switch to the platform, and I will show you how the platform looks like. Oh, I'm sorry, it's going to be a little bit later. So sorry, Kostiantyn. Yeah, if we could yeah, switch back. And yeah, the next slide would be yeah, the burned area, and I think yeah, that Kostiantyn will cover this one.
Yes, thank you, Yevhenii. Now we talk a little about burnt area solution, and to demonstrate the solution for this, this solution, we chose an area of interest in California, USA, where a massive wildfire occurred. This event took place the fall of 2022. The fire damages more than 70,000 hectares of forest. As an example, we selected a small part of this area, measuring 2,000 hectares. The solution is based on optical satellite images from Sentinel-2 with a resolution of 10 meters. Now we can see images before and after wildfire on this slide. After applying our solution, we got the following results. This mask for August displays the forest condition before the fire. As you can see, almost the whole area is forested, and there are no signs of forest damage. Gray colored territory includes any land cover which isn't forest, like roads, water bodies, you know. And this one for September shows the forest condition after the fire. We classified 4 levels of forest damage: unburned forest, forest which doesn't have any damage from wildfire; low severity damage, forest with minimal damage; moderate severity damage, the fire caused severe damage; and last, it is high severity damage, forest is almost completely destroyed by fire. The amount of damage levels can be increased depending on the characteristic of forest stand, but we recommend using exactly these 4 levels. The first step for analysis is to construct an land cover mask. This is necessary to determine the boundaries of the forest. After that, we calculate the NBR index for the forest area and do it post-processing. For this, it is critical to have a completely cloud-free images within the area of interest after the fire. I think that's all. Yevhenii, maybe you want to add something?
No, yes, thank you, Kostiantyn. So yeah, basically I just wanted to sum it up that this service could be used for assessment of the fire damage because nowadays we can see that more often and often we have fire events across the globe. So basically this service will help you to understand what area has been damaged and what is the severity of this damage. Plus, this service could be combined with other services, for example, like forest cover. So we could tell you what was forest cover before the fire and what is the forest cover after the fire. So this could be the application of this service, again, for the inventory and also for understanding what area has been damaged and what area still has some forest cover left. Also, we have some case, for example, one of the clients, they had a request from Turkey. As we know, there was a massive fire back in 2022. So this organization, they wanted to understand if damaged forest area still has the same application as before. So this area still stays under the forest and do not engage in any other activities, for example, like agricultural, or basically hasn't been illegally occupied by any other businesses or production. So basically to understand that, like this forest area, the area will be preserved so the forest could recover. So any like construction services or anything else would happen on this area. So again, we will analyze any case in more detail. So guys, if you have any projects or any cases that you think that forest monitoring could be applied, just drop us email and we'll be able to analyze your case as well. Moving forward, so next one is reforestation. So again, this is the service that could be applicable for understanding the recovery of the forest. So we could provide the information with a high frequency of update, but usually we recommend 6-month or yearly updates because it's a slow process. And reforestation could be applicable for different kind of projects. It could be carbon projects. We have some carbon project developers who basically initiating reforestation or afforestation projects, for example, like RED++ by Vera methodology. And they need to understand what is the rate, what is the level of reforestation. So basically, this is the service that we use. And here on a screenshot, you could see the use case from Indonesia. I think this is West Jakarta. So here we have this patch of forest. And as you can see in the middle, this is highlighted in red. This is deforested area. So basically, this area is cleared. It's been deforested. I think this is most likely commercial harvesting. And on the next slide, we actually see the reforestation solution. So here we could see that this area is highlighted gray, meaning there is no forest cover. And after a couple of slides, we will switch to the platform, and I'll be able to explain to you how it looks like in the platform, so you'll be able to see it more clearly. We're just gonna go through this couple of slides here. So as you can see on this slide, so this area is completely grayed out, meaning there is no forest cover. We're looking at the year of 2019. And then looking at the next year, we could see that some of the area is identified as forest. So basically our technology identified forest and non-forest based on a certain criteria. So basically once the trees reaching certain height, so this area will be classified as forest. So it's not like all the area will be classified of the forest, even if there is, like some young trees or shrubs. And on the next slide, we could see how this area is completely reforested. This is year 2022, so we could see that it took 6 years for this area to rebound back. And basically on this slide, we could also see that already commercial harvesting is going on again. So again, it could be maybe some fast-growing tree species like eucalyptus and so on. So basically here we could see that reforested area already has identification of deforestation, so basically of the commercial harvesting. And now, yeah, we'll ask Kostiantyn to switch to the platform so we could show you how the solution looks like and basically explain on this example in more details. So yeah, this is the platform. On the right-hand side, you could see all the solutions available on a platform like Deforestation, forest cover, Reforestation, and so on. Also, you'll be able to see all of your stands next to the features here. Right now, you can see all of the stands. So it could be any number of forest stands that you have. So if you have hundreds, it could be hundreds in the same place, providing data analytics. And here right now, you see the platform. So as I said before, this is the case from West Jakarta. So here we could see that in 2016, this area is completely deforested. So we could see deforestation mask highlighted in red. So this is the area which has been harvested. Also at the bottom, you could see statistics at this pie chart. You could see what area is deforested, which is 17.5 hectares. This is 3% out of total forest area, which is available at this particular stand. So all the statistics will be available as well. And then we could see next year is 2018. So basically we could see that it's highlighted in gray. So this is the area without any forest cover. So it means that this area is completely deforested. So there is no sign of forest. And while we're moving further, we could see that more and more area around the stand has been deforested, especially at the north of this forest stand. And if we go to the next year, 2020, we could see that this area is highlighted as non-forest. So basically, meaning that we're going to show deforestation, which has happened only for that particular year. If deforestation happened in 2019, so we're looking at year of 2020, it's not highlighted as deforested. So that meaning that deforestation happened earlier. So as we can see here, all this area is completely deforested. So no forest cover. And then here we're switching to reforestation solution. We're looking at year 2020, and we could already see some signs that around that area there is reforestation happening. So basically, we've been able to spot that certain part of the forest reached that minimum level that could be identified as the forest. And year 2022, we could see that the area is highlighted as forest completely, meaning that within 6 years, this area has been able to bounce back, and we could see that the forest cover is restored. Also, if we switch to other charts, from the pie chart to the historical information, we could see the growth of the trees, of the biomass level, the progression by year. So here you can see on the left-hand side, this is hectares. So we could see that from 10 hectares in 2020, it reached about almost 20 hectares in 2021 and up to 30 hectares by the end of the 2022. So you could also see the dynamics. So basically, we could see that the most growth happened between 21 and 22. So this kind of information will be available in a platform, again, depending on what solutions you will choose, either deforestation or reforestation, or all the solutions can be combined, and we could provide information about deforestation as well, as you can see right now. So in deforestation, we could also see the historical data, as you can see on the chart. So at what time period deforestation happened the most. So as you can see on the bottom, the year 2019, we have the most deforestation happened. So about almost up to 35 hectares of this area has been deforested. So all this statistical information here will be available in the platform, and you'll be able also to download reports, not only view this information in a platform, but also you'll be able to download the reports in Excel file format if you need to share this report or basically store it for your own record. And you could download report not just for one stand, but also you could download the report for all of your stands, depending on what service you selected. If it's deforestation, so you can download the deforestation report for all of your stands. So basically, yeah, this is just a brief peek at the platform, and let's move forward to our next solution. And here I would like to pass the floor to Dmitry.
Thank you. Forest health is characterized by the normalized difference vegetation index, NDVI. Changes in forest health are assessed by comparing the current conditions with the baseline. The baseline is past forest health at the same time of the year. The choice of baseline depends on the objective. For example, to detect forest disturbance, the current condition of a forest is compared to its undisturbed condition. The undisturbed forest has the maximum health or maximum NDVI achieved in the past during the same time of the year. The number of years over which the maximum is counted determines the ability to detect relatively short-term forest disturbances such as drought or long-term disturbances such as forest degradation. The greater the number of years used for comparison, the more long-term disturbances can be detected, but the ability to detect short-term disturbances decreases. Forest health is assessed monthly to overcome the effect of cloud cover. Depending on user and regional requirements, the interval between assessments can be reduced. The map shows the effects of a forest fire in the first half of August 2022 near Covilhã in Portugal. The footprint of the fire is visible as red patches covering a right part of the scene. The reduction of NDVI in the burned area is very significant, amounting to more than 40% compared to the 3-year maximum baseline. The condition assessment was performed for trees only, not for the other vegetation. The spatial resolution of the data is 10 meters. Forest biomass represents the potential amount of carbon that can be added to the atmosphere as carbon dioxide if the forest is cleared and/or burned. We calculate above-ground biomass, which is all living vegetation above the ground, including stems, stumps, branches, bark, seeds, and leaves. Machine learning models are used to calculate biomass. Training datasets are generated from ground truth data, satellite imagery, digital Earth models, forest species maps, forest age maps, and other ancillary data. The accuracy of biomass estimates is highly dependent on the data provided by the customer, the estimation method, and the region. Biomass calculation models also depend on the data provided. For example, if the customer provides forest inventory data, tree height, diameter, basal area, and so on, allometric equations can be used to determine biomass. Such models are usually more accurate than machine learning models. In addition to above-ground biomass, stocks of other forest carbon pools can be estimated. Below-ground biomass, woody debris, and litter. The map shows an estimate of above-ground biomass for a test plot in Argentina for the year 2021. Biomass estimates are made annually. The spatial resolution of the data is 100 meters. We use the Fire Weather Index, FWVI, to assess fire danger. This index takes into account the influence of fuel moisture and surface wind speed on fire initiation and spread. The higher the FWVI, the more favorable the meteorological conditions are for wildfires. FWVI was developed in Canada and is used worldwide. Forest Monitoring provides a map of fire weather at the current date and provides a 7-date forecast. The spatial resolution of the data is 10 kilometers. A global fire weather map on July 28 is provided on the slide.
Zhenya, the mic is off.
Thank you, Vera. Yeah, just carrying on. I forgot to turn it on. So yeah, I was just saying, yes, I just wanted to sum up the solutions that Dmitry has covered. It was very scientific and informative. So for the forest health, as Dmitry mentioned, we could provide estimation of the forest disturbance, if it's like long-term or short-term disturbance, including such effects as droughts, or if this degradation is caused by any diseases or pests, which actually is taking place a lot, degradation of the forest due to disease. In biomass estimation, yet the service could be used for the estimation of the carbon credits. This is something that we're working right now to add the service which allow us to calculate the exact amount of the carbon credits. But yeah, the forest biomass also allow us to make the assessment of the volume of the trees, which could be used for understanding if it's time for harvesting yet. So, and also basically this service could be used for multiple application. Again, if we could calculate the forest biomass, there is a lot of formulas that we could use to calculate other derivatives like CO2 absorption and so on. So this is something that we have actively developing in our company to provide complete carbon solution in forest monitoring. Switching back to additional information that we have, this is fire weather index to understand the potential threat of the wildfires. And this data combined with our information about the weather, we have access to historical data, and also in a platform we provide the forecast for 14 days. So you can make a historical assessments for a couple of decades back, since years of 2000, to understand what was the, for example, the precipitation level at your forest stand. But also you could check the current weather forecast if you're planning to do any activities, just to understand, for example, if the machinery will be able to pass to the forest area, if the road's accessible, or by looking at the precipitation, again, at the trend, at the historical information to understand what actually could be the potential of the wildfires, how long there were no precipitation in your selected forest areas. Plus also we have additional indices, and Kostiantyn will cover them next.
Yes, thank you, Zhenya. Of course, our product doesn't just consist of complex solution. Very often the information which we need can be delivered from simple indexes. The product can provide information on 5 indexes. It is NDMI, NDVI, RECI, MSAVI, and NDRE. You can independently access information of these indexes and draw conclusions about vegetation efficiency, moisture saturation, and other factors. The correct selection of indexes for monitoring can play a crucial role in sustainability forest management. But we don't limit our size to just these 5 standard indexes. We also offer the capability to add any custom index within the framework of our model, custom indexes. This significantly expands the amount of information available to our users. So, Yevhenii.
Kostiantyn, thank you. And yeah, right now, guys, we will have a short survey. It will be 6 questions that I will ask you to answer. It's really simple. So first 5, you just need to select the answer. And yeah, the last one, number 6, you just need to provide maybe a 1-sentence answer. So this will help us to better understand what is the requirements, what are you looking for from the forest monitoring solution. So for example, like first question, which of the proposed services would fit your company or organization need the best, if it's deforestation, forest cover, tree species identification, forest health, burned area, biomass estimation, because we are constantly looking for feedback from our clients to understand in what direction to go. So this feedback will be also valuable from your side. I see that you're actively participating. Thank you so much for doing so. So yeah, we still have a couple of minutes to finish the survey, so please take your time. So yeah, the next question, for example, number 2, if you would like to receive any analysis, any feedback from us about your forest area, so you can basically just drop us email by using any of the contact forms that we have at our website. Or if you would like to know more about some of the services in more detail, so yeah, you could also make your requirement, and we'll be able maybe to set up a demo call with one of our specialists, or just reply you via email by providing more information. Yeah, let's have a couple of more minutes to make sure that everybody will finish all the questions. Yeah, and the number 6, yeah, this is open-ended question, so please feel free to provide your own answer. Being a little bit creative here. Okay, guys. Yeah, I see that we have a lot of answers submitted. So let's wait maybe one more minute before we're gonna carry on with our presentation. So we have another segment prepared, and we will dwell on sustainability because yeah, the application of forest monitoring service is not only for like the commercial application, but also we have a lot of cases that we help with our solution for nonprofit organization. But also, yeah, it's a very good case how this service could be used in other realms, not just like the assessment of deforestation, but also how we could contribute to local communities and how we could combat the climate change or any other factors that have the influence on the forest, and basically what information could be helpful to combating this effect. So yeah, I see that we have submitted most of the questions. So thank you so much for participating in this survey, and yeah, certainly this information will help us to provide more feedback, and yeah, definitely if you'll submit any of your requests, so that would be great. And now, yeah, I would like to pass the word to Vera to cover the sustainability. So Vera, the floor is to you.
Yeah, hi. Thank you so much, Yevhenii. I'll be very short. I know you guys been listening for a while, so I'm not going to spend a lot of your time. I just want to combine what are the problems we are solving. So in terms of sustainability, we are identifying illegal logging, we're tracking reforestation and deforestation efforts. We are defining the type of trees. As you've heard, it's very important to understand what kind of tree and what kind of soil is planted on. What we do, we provide the evidence of forest condition for decision making. So in doing so, we hope that we are not just helping you observe the problem, but we're equipping you with the tools to make a positive impact. So who is our target audience? Our target audience is not individuals. We're working with businesses, large businesses, medium businesses, small businesses, and of course our main target are governments. So for landowners and forest managers, what you can do, you can utilize the system for effective forest management planning, monitoring forest health, identifying types of trees, and of course tracking illegal deforestation. Financial institutions and investors are among our top priority. We have a lot of requests from banks who are giving loans, and insurance companies who need to understand the forest health, its history, and its profitability in the future. We're also working with food producers so they can track the progress of forest landscape restoration efforts and generate zero deforestation, which is very important right now for the European Union countries, because in 2024 there's going to be a European Union deforestation regulation taken into action, as well as in many countries all over the world. So we can help with that as well. And as I said before, governments are a main target because they are the decision makers. They can not only help businesses equip and use our platform, but they can also make the rules so we can help fight the climate change and at least adjust to it at this point. So to tell you that we're not only saying this, we are aligned with 10 out of 17 United Nations goals for sustainability, which are climate action, clean water and sanitation, affordable and clean energy, and so on and so forth. And that's why our mission and vision is very much aligned around sustainability. The mission is pretty clear. We want to give you the data so you can make accurate decision and make it cheaper, make it faster, as usual. But our vision, as I usually say, our dream is to make space tech a global driver of sustainability on Earth. And so you don't think we're only saying it for the sake of PR. All of our services and all of our products, as I said, align with United Nations sustainability goals. And we in the marketing PR department are working closely with the indigenous communities or nonprofit organizations who are seeking help from satellite data and who can benefit from it to solve the problem or at least to bring attention to it. On the slide, you can see my top 3 favorites. The first one is about oil spill in the Amazon. Unfortunately, my very favorite country, Ecuador, has suffered very many times of the illegal oil spill, and we could show, and the government was saying that it was not true, but we showed it with the historical data that yes, it happened, and we brought a lot of attention to it. The second is the Munduruku people who suffer from the gold mining, again, illegal gold mining, who destroyed half of their forest, their habitat. And my personal favorite, the Chad case, is the case where the amazing eco-activist Hidu Ibrahim reached out to us so we could create a 3D map to actually solve the problem of the resources. Because of the climate change, people who are living in communities started fighting for the greener land. And with the satellite technology, we could create the map that showcased the forest, the water, the agricultural land. And I'm very happy to say that a year later, we just had a call with her. We have solved partially this problem, and the map has been actually put it into account on the governmental level. I guess this is it from my side. Thank you very much. If you have any cases like this, please reach out to pr@eosda.com. Thanks.
Vera, thank you so much. It was a great presentation. So guys, as you can see, we also participate in the sustainability cases, as Vera mentioned. And moving forward here, I just wanted to say a couple of words about EOS SAT and its application in forestry. So as I mentioned before, at the beginning, we have launched this satellite, and this is agri and forestry focused satellite. So the data will be used to enhance our existing solutions and also to develop new solutions in regards to biomass estimation, carbon markets, or basically to provide more accurate insights. So here you can see some of the examples of this data. Right now, yeah, the satellite in the commissioning phase, meaning that there is some additional testing is happening, but we already receiving the data. So here you can see some of the examples. I think, yeah, the image on the top, this is from Segovia region from Spain, and at the bottom to your left, this is image from United Arabian Emirates. So as you can see, the resolution is quite high. It's 2.8 meters multispectral resolution. So we use this data combined with Sentinel-2. So they have some other products like data fusion developed. So this data will help us to provide even better insights. This is just a screenshot from the moment of when the satellite was actually released from the launching system. And here you can see that actually it's there. Again, another example, just to give you an idea about the resolution. And again, the application of this data is not only like natural view, but this is also the analytics that we provide. So the masks of deforestation and forest cover that our specialists will generate for your project areas. And in our company, we have plans for development of the solutions beyond year of 2030. So we're planning to establish constellation by the end of 26, 27, and also there would be additional satellites launched within the nearest time. And again, the advantage of this data is the ability of our company to have access to our own source of data. So in these terms, we will be much more flexible because we could provide tasking, so we could decide what areas we could take the imagery, so we could change the course of the satellite and tilt the camera and be able to capture the area of your projects that you need. So this way, we are becoming more independent, and yeah, with access to our own data, we could provide more flexible solutions with the higher resolution for basically for your decision making. And right now, so we would like to switch to our Q&A session, and we have questions received, and I will go through the questions and I will try to answer your questions. If not, we will get back to you by email. So I see that Kirill did a good job and he prepared a lot of questions here. So the first question is, what methodology do you use for deforestation identification? So basically, yeah, we for deforestation, we apply the time series of the images. So we track the changes at the beginning, at the end of the period when deforestation happened, and track any changes that happened during the course of the year. Also, yeah, we could have like a custom dates in a platform, so it could be done on monthly or like quarterly periods. So basically, we will make the assessment based on the changes that happened on the analysis of the time series of the images, in this case, Sentinel-2. Next question, export the deforestation areas polygons. So at this moment, we do not have these functions in a platform, but we could do it easily. So if it's required by the client, so we could deliver this information basically tailored to your requirement. Next one, how do you differentiate between natural forest plantation and commercial forest? Yeah, unfortunately, at this stage, we like do not have the solution for this identification, so we cannot tell which is artificial or, for example, is natural. But we could, again, depending on what kind of imagery we will use. If we use Sentinel, so yeah, in that case, we cannot tell. But if we will use higher resolution imagery, so in that case, we could identify if it's like any natural forest. But in this case, yeah, the cost of the solutions would be higher since we would need to acquire commercial imagery with a higher resolution. So basically a lot of things possible, and we just need to understand your request better. Why do you need this for? And yeah, what is the objectives of the project? Next one, have you ever analyzed the cases of deforestation in Morocco? Yeah, it's a tough one. I'm not sure if we have any cases from Morocco since yeah, our solution is relatively new. And I know that we have clients in Morocco who's using our agro platform, but about the forestry, I'm not sure yet, but yeah, we'll definitely find it out and get back to you if you have any cases in Morocco. The next one, would you have free of charge products for forest and agriculture spatial analysis for Africa or developing countries? Actually, yeah, we have academic program. If you go to our website, there you can find academic program for students, non-profit organizations, scientists who could apply and who could have access to our solutions like crop monitoring platform, forest monitoring platform, all in euros. So basically, this is free access for some limited time. So yeah, this program is available at our website. So please go and check it at our website. Next one. Have you ever made interventions in Morocco, whether in the forestry or agricultural field? Yeah, I see that some of the users really keen to find out about Morocco, and as I mentioned before, we have cases, we have users who are using our agricultural solution for monitoring agricultural land or orchards in Morocco. But for the forestry, this is something that I need to find out. But definitely we have cases in Morocco in regards to agriculture. But if you will share your case, what in particular you would like to track in Morocco, what forest areas, we'll be happy to provide our feedback. Next one. Are raster outputs available as services that could be consumed within other apps like ArcGIS Pro, ArcGIS Online, Vue.js, and so on? This is a great question, and actually we could deliver the results in different file formats. It could be raster or vector masks. We could deliver them via email or make it available for download on a Google Drive or deliver them via API. So basically any preferred way that you would like to receive this data is possible. Next question. What is the maximum area that could be analyzed? So there's actually no limitations in terms of the size of the area, so we could analyze any area. Perhaps we could, for example, like distribute this area to smaller segments to make it like more easy to analyze. Usually we analyze area by the size of Sentinel-2 tile, which is 10,000 square kilometers. But of course, if this is a smaller area or if it's a larger area, we will adjust, but there is no limitations in terms what area size we could monitor. Next question. It's a great question. How does your system apply with insurances? So basically, our system could be applied to make an assessment. So we could have a look at the historical trends about forest cover or deforestation to understand what is happening there. So basically, insurance companies, first of all, they could make assessment of this area on the subject of the forest inventory. What is the forest cover? What is the volume of the forest? And also they could have a look at the historical trends to understand what is the dynamics of that forest cover. So basically this is assessment and this is other analytics. For example, if you need to have ongoing monitoring on monthly basis to understand if there is any changes happening, or make the assessment of the forest, as Dmitriy was telling about the health of the forest, if there is any droughts or any other disturbances. So again, depends on your objectives. What is the objective? What is the data that you would like to get? So we could provide those data sets. The next question about carbon credits. Are you planning to have the technology approved by the various registries for use in the carbon development projects? This is actually what we're working on. We are working on developing our solutions for the carbon markets. And this is also possible that we will have certification from like global organizations, which is available out there at this moment. So this is in progress, and we will keep you updated since we are working on developing our solution and making it applicable for any cases, and especially for carbon credits, which is a hot market right now. Do you have any space solutions for hydrology projects? This is a tough one, so we will get back to you later. I'll need to speak with our scientists if we have any application. But as I mentioned before, our main focus, this is agriculture and forestry, but I'll find out about hydrology projects because we have some custom projects in mining that we are doing right now, so perhaps we could also help you with these hydrology projects. But if you could please maybe drop email telling us a little bit more about this project, so this would be helpful to provide your feedback. And I think this is the last one, and we've pretty much got up to the questions. So how to calculate or measure atmospheric pollution based on the deforestation? So let me check. I see that Dmitry is helping me out here. So let me just 1 second. Okay, so basically we could make the assessment of the atmospheric pollution based on the deforestation by making assessment of the loss of the biomass. So if I'm articulating this clearly, so basically we can make the assessment of the CO2 which is released to the atmosphere by assessing loss of the biomass. So for example, if the biomass of the forest is decreasing, that means that the CO2 release is increasing. So, but also, yeah, the assessment depends on the type of pollution. So it's not always, basically there is like no definite answer here. But yeah, as Dmitry replied here, so it could be done by making assessment of the biomass. And if we see that the biomass loss is high, so there is high probability of the increase of CO2 in the atmosphere. Thank you, Dmitry. It was scientific support from Dmitry's side. And I think that we covered all the questions. So guys, if you have any other questions or if you would like to receive our feedback about your projects, please feel free to drop your email to our email at sales@eos.com and we will provide our feedback. And yeah, right now, I would like to thank you everybody for your participation, for taking your time on this summer day with us, and for basically being able to watch our webinars. And yeah, together with my colleagues, we would like to thank you again and wishing you a great day and see you at our next webinar.
Thank you so much. Have a peaceful day.
Thank you. Bye-bye.
Thank you for your attention and goodbye.
Thank you, guys. Take care.
Bye.